Hello all, good morning. This is Dr. S. Subbalakshmi, an assistant professor in the Department of Mathematics, SNS College of Technology. This is a lecture video series on the course Matrices and Calculus, and now we are on to the topic volume of solids. In volume of solids, we implement the multiple integral techniques. In the previous videos, we have seen the design thinking approach on volume of solids and the case study video on volume of solids. Here we are going to see the formulation of the volume of solids using multiple integrals, which means the triple integrals. The question is, find the volume of the sphere x square plus y square plus z square is equal to a square without the transformation, which means we are not going to change the order of integration here, and we are going to find the volume of the particular sphere. So here we are given with the equation of the sphere, and what will be the volume? Volume is nothing but 8 into volume of the first octant. In the sphere we will be considering some 8 octants here, and we will be finding the value of only the first octant, so that we will implement 8 times to get the volume of the whole sphere. So what about this volume? Volume is nothing but triple integral over R dz dy dx, the usual application. Triple integral over the region R dz dy dx. The first variable of integration is z, second variable of integration is y, and third variable of integration is x. So we are in need of finding the limits for each of the variables. Firstly, we are going to find the z limits. What will be z limits? Using the given equation, it is x square plus y square is equal to plus z square is equal to a square. With this, we will be finding what is z square. Z square is equal to a square minus y square. And what is z? Z is equal to root of a square minus x square minus y square. Now, what will be the y limits? For finding y limits, we have to put z is equal to 0. Therefore, x square plus y square is equal to a square, and y square is equal to a square minus x square, and y is equal to root of a square minus x square. In a similar way, we are going to put y is equal to 0 and z is equal to 0 to find the values of x here. So what will be x? X is equal to a. So we will be substituting all the values of all the limits of x, y and z to the integral here. So as shown here, x is equal to 0 to a, y is equal to 0 to root of a square minus x square, z is equal to 0 to root of a square minus x square minus y square. So what will be the volume? Volume is nothing but the triple integral 0 to a, 0 to root of a square minus x square, 0 to root of a square minus x square minus y square, dz dy dx. So on integrating with respect to z first, we will have z here within the limit 0 to root of a square minus x square minus y square. So what will be the upper limit and lower limit substitution here? Upper limit substitution will bring you root of a square minus x square minus y square minus 0, the lower limit dy dx. On retracting it, we will have this alone. This is dy dx alone. So on integrating with respect to y, we have this can be formulated as root of a square minus x square the whole square minus y square. This can be formulated as a square minus x square. This can be formulated as a square minus x square. So here a is root of a square minus x square and x is y. So on implementing it in the formula for integration, root of a square minus x square dx, which we will have it like y by 2 root of a square minus x square the whole square minus y square plus root of a square minus x square the whole square by 2 into sine inverse of y by root of a square minus x square within the limit y is equal to 0 to y is equal to root of a square minus x square. So this is how we integrated. Now later, what have we got here? We have just implemented the upper limit and lower limit here. What is your upper limit? It is root of a square minus x square. On substituting it, you will have 0 as the first term, and here if you substitute this sine inverse of x, you will have sine inverse of 1, you will have sine inverse of 1, and sine inverse of 0 will be 0. So this is how we integrate and substitute the upper limit and lower limit. Later we will be integrating with respect to x alone. So what will be the remaining terms? What is sine inverse of 1? It is pi by 2. So on taking this pi by 2 outside the integration, you will have pi by 4. Integral 0 to a square minus x square into dx. So on integrating this as usually, what we will get? We will get a square into x minus x cube by 3 within the limit 0 to a. On substituting the upper limit and the lower limit, we will have the value as a square into a minus a cube by 3 minus 0. This can be taken as an LCM. This is 3a cube minus a cube divided by 3, which is nothing but 2a cube divided by 4 into 3, which is pi by 12. So what is the integral value? It is pi by 6 into a cube, and we knew that volume is equal to 8i. 8i, which means 8 into the volume of the first octant, so it is pi by 6 into a cube. On simplifying it, we will have the volume of the sphere as 4 by 3 into pi a cube. So this is how we implement multiple integrals to find the volume of the particular solid given. Thank you.